Hello students, hope you are all doing really well. So we were doing the chapter periodic table, periodic properties and variations of properties which are there, and in the previous class we had discussed for children the different classifications that were given by different scientists regarding the elements which were there. We discussed about the modern periodic table. Then we discussed about what children? We discussed about the shell, the groups and the periods which are there, the S, P, D and F block elements. Now today, as we proceed children, we will be moving to the new topic that is called your periodicity. Now we'll be discussing what is periodicity. So if you see, the periodicity is called what? The property that reappear at regular intervals or in which there is a gradual variation. Now what happens children, as the words say, whenever we say that a particular property which is there or any particular event that is occurring again and again, we generally considered was that it is called a periodic event. Now what is periodic event children? Periodic in the sense that it tends to repeat itself. So when we talk about periodicity in elements which is there, okay, so this periodicity means what children? That there are certain properties that will tend to repeat itself, and this is happening what children? This happens usually down the period and else down the group which is there, and across the period the chances of periodicity is very less. Why? Because the only reason for periodicity is children the electronic configuration of the elements which are there, and the electronic configuration means what? Usually children, if you see down the group, the electronic configuration is usually same for all the elements which are there. Like if I want to explain you this out, see here, if you see, just a second children, here if you see, now if I take the elements which are there, suppose F, Cl, Br, then I have I, and then I have At, that is atomium. Then this is my atomic number, here happens to be 9, this is 17, this is 35, this is 53, and this is 85. Now if I move to the electronic configuration children, this is 27, this is 287, this is 28187, this is 28187, and this is what children? 28, 18, 32, 18 and 7. So this is my electronic configuration down the group. Now children, you know that what is responsible for a reactivity of a particular element is the number of electrons which are there in the outermost shell. Now here if you see children, what is the number of electron in the outermost shell? This is equal to 7. Here also it's 7, 7, 7 and 7. All the number of electrons in the valence shell is equal to 7, which further means what children? Which means that these will be having same electronic configuration, and then they will be showing similar properties upon reaction with another metals. Now this very particular property is called periodicity children. If we see, the periodicity is actually what children? In that the properties they tend to reappear. Means what? Suppose I am having, suppose an element that is F is having high melting point, then as we move down the group, this property will be either remaining same or what? In the periodicity you can have a gradual increase or decrease which is there children. What do you mean by gradual? It means that there will be a slight increase, and it's not like that from F to Cl if you move you'll be having a very large increase. No, there will be step increase or decrease as we move down to the group. So this is called my periodicity. Means what? Either will be changing in a very small form in the increase or decrease form, or else the property remains the same. This is called my periodicity. And what is the cause of periodicity? The cause of periodicity is children electronic configuration, which in turn depends on the number of electrons in the valence shell. Okay. So this is my periodicity. Now if you see the thing which is given in your textbook, children, the electrons in the outermost orbit, it remain the same. That is, my electronic configuration is similar. This is what I have discussed before also. Here if you see, children, in the outermost shell the electrons are same, hence we have the same electronic configuration. So since the chemical properties are dependent upon the number of electrons in the outermost shell, thus the elements of the same group have similar properties. They are not saying that, children, they are having same property, but we say that the properties of similar means what? Even if there is a change in the property, the change is first of all very small, and second of all it is gradual. Means what? Step by step it is increasing. It's not that there will be sudden increase down the group. No, there will be a gradual increase. So this is my periodicity which is there. Now for example, if you see whatever is given in your textbook, children, see, this is the thing. If I move to the properties of group 17 elements, children, this is my group 17 elements. There are few properties. The first property which is there is they formed colored non-metals. Though not they form, they are colored non-metals. Okay, so this is a property which is tending to repeat itself. It's not necessary that all of them are having same color, children, but it's just that they are all colored, and this also defines the periodicity. Why? Because this property is tending to repeat itself down the group. Okay, and this is not there across the period. This property is only there down the group. Now if you see, they all carry negative charges within them. Okay, and hence they formed what? Single positive charge. Okay, they are negatively charged and they are single negatively charged. The third one is of course that they are very reactive. And what is the reason that they are reactive? There is that they are having 7 electrons in the outermost shell, children, and they are lacking only 1 electrons. Just they want to gain 1 electron from anywhere. If they are gaining 1 electron, then they will be attaining the noble gas configuration which is there, and hence they are always very reactive just to gain that noble gas configuration. So they are very reactive, and then this is the reason that they are found in combined state. Okay, this is also one of my property. Now if I move to this fourth property which is there, we'll see that it is only slightly soluble in H2O. Okay, so this is slightly soluble in H2O, but it is very nicely soluble in organic solvent which is there. So you will write what? That in organic solvent it is fully soluble. Now if I move to the fourth point, children, it is that they are having very their melting and boiling point, they increase regularly moving down the period. Means what? For fluorine it will be a bit lower, then as we move down the period, then down the group, what you will write? Down the group MP and BP increases, boiling point increases. And the last point of course is that they are very good oxidizing agents which are there. Now when we talk about oxidizing agents, children, what is oxidizing agent, children? Means what? They will be oxidizing the things, they will be oxidizing another elements, and they themselves will be reduced in the reactions which are there. So this is the example of the thing that they are very good oxidizing agents. Now if you see, children, this property which is there, this increases as we move down the periods which are there, move down the group which is there. So this is the reason we say that what? These properties are repeating periodically, or else it means that these properties will be seen down the group which is there. So what is the meaning of periodicity, children? The meaning of periodicity is that these properties will be recurring, these property will be seen in the elements which are there with a gradual increase or decrease which is there. Now if I see See, now if I move to the next topic, children, my next topic is shells and valency. So we'll be moving to the next topic. The next topic is called, we'll see. This is my next topic, that is shells and valency. So we'll discuss this, children. What happens here? See, if we see, now see, down the group what is happening. First of all, I'll let you know what is shells, children. Suppose this is my nucleus, and then around this there are orbits in which the electrons revolve. Now these particular things, these are called orbits, or else these are also called shells which are there. So shells or orbits are the parts or the circular parts in which the electrons revolve. So this is the definitions of my cells of orbit. Now what happens, children, as I move down the group, what will happen from top to bottom? If you see, this is my F, Cl, Br, I and atomium. Now what is happening? If I am moving down the group, children, if you see the number of shells, they tend to increase repeatedly. Like here I am having 2, 7, this is 2, 8, 7, 2, 8, 18, 17. So how many number of shells are there, children? If you see, the number of shells that I have here is only 2. Here I am having 3. Here I am having 4, here I am having 5, and here I am having 6. So what is happening? As I am moving down the group, the number of shells are increasing, and the number of shells which are there, that is equal to the group number of the particular atom. Suppose in fluorine I am having 2 shells. So what is the period of this fluorine? Fluorine belongs to the second period. Similarly, children, chlorine belongs to third period. So what do you see here? Iodine will be belonging to fifth period, children. The thing that we observe here is that the total number of shells is equal to the period number of the elements which are there. So this is an important property of the number of shells or valency, that first of all what is happening down the group, number of shells which are there, they tend to increase, and then we'll see what happens if we move across the period. Now if I tell you the example of across the period, children, see, I'll be writing down the examples here. Suppose I am having across the periods element like this, starting from lithium. If I start with, okay, I am having lithium, then I am having beryllium, then I am having boron, then I am having carbon, nitrogen, oxygen, fluorine, and then I am having neon. So for lithium, what is my electronic configuration, children? 2, 1. For beryllium, I am having 2, 2. Boron is 2, 3. For carbon, I am having 2, 4. Nitrogen is 2, 5. Oxygen is 2, 6. Fluorine is 2, 7. And then neon is 2, 8. So here what do you see, children? If we count the number of shells which are there, the number of shells here is equal to 2. Here also it's equal to 2. Here also it's equal to 2. So what do you see? Across the periods which are there, the number of shells tends to remain the same. So what is the conclusion that we are drawing about the number of shells, children? That as we move, so in order to summarize this, I can write down like this: shells, okay, or else you will write their number. So across the period, what happens? And then the second thing is down the group. So as we discussed, children, what is happening across the period? Across the period, the number of shells tends to remain same. Okay, so write down it remains same. And what happens to the number of shells down the group? It increases down the group. So this is the important property, and the number of shells, as they increase down the group, the number of shells in each group will give me the period number of that particular element which is there. So this is an important property. Now children, now I will move to the second important concept which is there in this chapter, that is called valency. Now if you see what is valency children, valency is defined as the combining capacity. Now what is combining capacity children? See, suppose I am having an element which is there. So valency here denotes the combining capacity. It is equal to the number of electrons an atom can donate or accept. So it's not necessary that in valency an atom will be only accepting electron. It's a very possible chance that it can donate also, but the condition is that children, they should be able to attain the noble gas configuration. Now if you see children, there is a very easy concept of valency. Okay, now see, first I'll let you know what is valency. So if we talk about valency, this is my combining capacity. Okay, so here I'll be taking example of groups which is there children. Before that, what I'll do, I'll just explain you a general trend of how to find out valency children. Suppose, see children, whenever there is number of valence electrons in the elements, it is always equal to 1, 2, 3, 4, 5, 6, 7 and 8. So these are the possible cases of valence number of electrons. Now how to find out valency children? Valency till 1, 2, 3, 4, the valency is always equal to 1, 2, 3, 4. Now as we move to 5, 6, 7, 8, the valency is not equal to 5, 6, 7, 8 children. For 5, the valency will be equal to 8 minus 5, that is equal to 3. For 6, the valency will be equal to 8 minus 6, that is equal to 2. If the number of valence electrons are 7, the valency will be equal to 8 minus 7, that is 11. And if the number of electrons are 8, the valency will be equal to 8 minus 8, that is equal to 0. Now, valency being 0 children, what does it mean? That it does not have a combining capacity. Now this is very much relatable children, since the number of valence electrons are 8 only for noble gases, and we all know that the noble gases are not reacting with any element. Alright, now if we move to the next concept children, the next concept is what happens to the valency as we move down the group and as we move across the period. So we'll be discussing this. So for this children, there is an easy concept. If you see, we discussed down the group. See, we'll be taking this example once again. Here what do you see children? Valency is defined as the combining capacity. Now here if I extend this, can you see what is happening? This is down the group. Here my number of valence electrons are equal to 7 in each case. Alright, if the number of valence electrons are 7 in each case, means what? My combining capacity will be same, because valency is very much and directly related to what children? Valency is directly related to number of valence electrons. Okay, so here what we see, that the number of valence electrons are same, so we can conclude that down the group the valency remains same. Now what is the children? Now we'll see what happens across the period. Now I'll explain you this with the help of example children. See, here if you see, write down. I'll be writing down here children what the elements of the second group, second period elements which are there. So they are Li, Be, then I have boron, I am having nitrogen, carbon, alright, then I am having oxygen, fluorine and neon. So what is happening here children? What is the electronic configuration of lithium children? If I want to write down, I'll write it down like this. The electronic configuration will be equal to 2, 1, 2, 2. here I am having 2, 3, then 2, 4, then I have 2, 5, 2, 6, 2, 7 and 2, 8. Now this is my electronic configuration of this particular, and this we are discussing, children, across the period. Now first of all I will explain, children, what is the difference between valency and valence electrons. So valence electrons are what, children? It clearly defines what? The number of electrons in the outermost shell. Electrons in outermost shell. So this is my valence electron. Now as the name suggests, children, if I want to write down number of valence electrons, here I am having 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So if I want to write down, children, I will write down like this, that here valence electrons are equal to 1, 2, 3, 4, 5, 6, 7 and 8. Now I'll move to the valency part. How to find out the valency, children? Valency, as I told you here, if I want to write down valency here, so this my valency here, it is equal to how much, children? If you see, I told you up to 4 the valency will be same. So it is 1, 2, 3, 4. Now if the number of valence electron are 5, my valency will be equal to 8 minus 5, that is equal to 3. Why? Because, children, the maximum possible value of valency is always equal to 4. Now if I move to 6, it is 8 minus 6, that is equal to 2. If I move to number of valence electron equal to 7, my valency will be equal to 8 minus 7, that is equal to 1, and here it will be 8 minus 8, that is equal to 0. Alright, this is the number of valence electrons and this is the number of valency. So what do I conclude here, children? That 1, 2, 3, 4, then I come to 3, 2, 1 and then 0. So what is happening across the period which is there? This is, children, if you remember, this is my group 14. Okay, then what is happening up to group 14, children? What happens? See the number of, see what is happening here. Okay, children, there is a thing which I wrote wrong here. It will be carbon and then nitrogen. Okay, so write down here, I have carbon, I'll write down with the black ink, and then I have nitrogen. So what do I notice? That in carbon, children, carbon is of group 14 which is there. Group 14, what happens, children? The valency tends on increasing, and then as we move towards group 17, the valency tends to decrease. So this is the trend which I observe in the valency. So to conclude, children, what can we write? That, see, I'll be writing like this, that what happens to the valency? Then we are having two things. One is down the group and the second one is across the periods. So what is happening down the group, children? Down the group, the valency is, first of all, what did we see? It remains same because the number of electrons in the outermost orbit is same. And what happens across the period? First, it increases up to 14. Write down, I'll write down with another ink, children. It increases up to group 14 and then decreases till group 17. Means what? The maximum possible value is 4 and then it tends to decrease. Now, children, in a short note, I'll tell you what happens actually, why it tends to decrease. Children, see, what what is valency equal to, children? This is a thing which is not there in your book, but I want to explain you this so that it is easier for you to increase that why all of a sudden it is increasing and it's going up to 4 and then it is again decreasing. Now children, if you see, what is my valency? It is my combining capacity. So I want to find out a way in which I can attain a noble gas configuration. Because why do I combine with elements? Because I want to attain noble gas configuration. So if I attain noble gas configuration, then I'll be stable. So for attaining noble gas configuration, suppose I am taking third period elements, alright, or else this is Ne, then Na, then Mg, Al, Si, phosphorus, then I am having sulfur, after that 11, 12, 13, 14, 15, 16, and then I'm having chlorine and then having neon. Now children, here if you see, neon is my, not neon, here I'll be having argon. So if you see here children, this is my noble gas which has the electronic configuration 10, and this is also my noble gas which has electronic configuration 18. Now if I want to attain stability, I'll either try to shift towards electronic number 10 or I'll try to shift towards electronic number 18. So if I am having electronic configuration of sodium which is there, so what is the electronic configuration of sodium children? It's 281, then I have 282, and then I have for aluminium 283. So what I notice children, I'll write down here 284 children. For this I am having 285, 286 and 287. So what happens here children, if you see that Na, Mg and Al, they want to attain noble gas configuration. So there are two ways children, either it can go to neon or else it can go to argon. So whichever is easier for them. So here if you see children, for sodium it is very easy for it to lose 1 electron and go to neon rather than gain 7 electrons and go to argon. So that is why its valency is only equal to 1, means I will readily lose 1 electron and I'll go to neon. Similarly for Mg, it is having 2 electrons, so it is having two options, either to lose 2 electrons or to gain 6 electrons. So easily what I'll see that for me losing 2 electrons is easy, so my valency is equal to 2. Now for aluminium, it can either lose 3 electrons or gain 5 electrons. So which is easier? Losing 3 electrons. So my valency is 3. Now for Si children, it is having 4 electrons. So it can either lose 4 electrons or it can either gain 4 electrons. So its valency is 4 because it has to lose or gain 4 electrons to attain the noble gas configuration. Now if you move to phosphorus children, here my electronic configuration is 285. So I have to either lose 5 electrons or I have to gain 3 electrons to attain noble gas configuration. So for me, gaining 3 electrons is much easier than losing 5 electrons. Similarly, for sulfur, what I will be doing, for sulfur I am having 6 electrons in the valence shell. So for me, I can either lose 6 electrons or I can gain 2 electrons to go to argon. So my valency is equal to 2. For chlorine, either I can lose 7 electrons or I can gain 1 electron. So gaining 1 electron is easy. So my valency is 1. So this is the reason children why this trend is observed in the valency. Okay, so this is the reason why valency first increases, goes up to maximum 4. Why it does not go to 5 children? 5 because here there are two options for it. Either it can lose 5 electrons or it can gain 3 electrons. So it prefers gaining 3 electrons as an easy way, and therefore the valency is equal to 3 for it. So this is the thing. Now we'll move to the table which has been given in your textbook children. So what did we observe? We studied 3 things children, that periodicity completely depends on the electronic configuration. Then we studied about shells. In the shells, what happens down the group? The number of shells increases. Okay, and what happens across the period? The number of shells remains same. Then we studied about valency. So for valency across the period, the valency shows gradual increase and then decrease, and down the group it remains same. Now this is the table that has been given, children. Just to summarize, here these are the elements: atomic number, electronic configuration, number of shells. If you see, these are the same period elements, so this is same. Valency is equal to 1 2 3 4, then it is again decreasing to 3 2 1 0. And formation of hydride, children, hydride formation is completely depend on the valency. Suppose Li and H, since Li has one valency, it will be forming LiH. Now for Be and H, so beryllium has a valency of 2, so upon crossing it becomes BeH2. So similarly, the formation of hydride is completely dependent on the number of valence electrons. No, it is completely dependent on the valency. Okay, suppose I am having C and H. What is the valency of carbon, children? 4. So upon cross, and this is 1, so when they cross, this becomes CH4. Now if you move toward NH3, the number of valence electrons in NH 5 and its valency is 3. And for hydrogen, the valency is equal to 1. So these tend to cross each other. So this becomes NH3. So this is what is the explanation part, children, how the formation of hydride takes place. This is completely dependent on the valency of that particular atoms. So I hope we are clear with the things that we discussed in this section. So we'll be continuing with the next section in the coming video.